That makes me happy.
So when you change this,
because 20y doubles up the end one into oh, so that's kind of annoying. Yeah, it is weird. But it makes sense mathematically, because if they're 10y, then you make it 20y, you're actually collapsing data sets together. So instead of going, for example, 59 to 69, and then 69 to 79, you're going 59 to 79, which actually that's weird. Well, that makes sense, because if you change your x min, if you make it too high, you're not going to be seeing the low ends. Right, I would say, that's why I always like to start with ZoomStat. ZoomStat puts it kind of in the right place. Makes sense? All right, friends, let's regroup. Let's regroup, make sure we're in the same place, make sure we're happy. Sorry. I'm trying to make, this is very light. I don't know why this is so light up here. This is maxed out here and the batteries. Oh, that's too dark. Okay, not bad. Now what I want to do is I want to input L3. You can, if you want, just get rid of L2 and put L3 on top of L2. If you did that, that's totally fine. But I want to put in L3, and I'll show you why momentarily. So L3 is going to be the frequencies for the bottom finishers. They're going to share L1. L1 is actually your data, correct? L1 is actually your data. We're going to share that with the top finishers. So I'm going to go to Stat, Edit. I'm going to leave L2 there. If you already erased L2, don't worry about it. It's totally fine. It's totally fine. I'm going to put the bottom finishers in L3. That's 1, 18, 28, 14, 9, 2, and 3. All's well. All's well.
If we already erased them, can we just put back
in
L3 the first one again?
Yes. Of course.
Okay.
Absolutely. Absolutely. I do want to show you one of the drawbacks of a TI when you're comparing data sets. Remember how originally today I had your heights up on the board, the bell curves of your heights? And it was nice because I could tilt them, and I had green and blue and red, and you could actually tell them apart from each other. Here's a problem. Suppose I wanted to compare the ages of the top and bottom finishers. I've often heard that runners get better as they get older, especially distance runners. Lady that won the Boston Marathon, the one that Emma ran on Monday, she's 39 years old, and she's an American, which is very unusual for a big international race like the Boston Marathon. Usually it's won by Kenyans or what are the countries that produce the good runners? Kenya.
Oh yeah.
Yeah. I can't. They're African, high savanna African countries. They train at altitude. They run their entire lives. They come to Boston at sea level. They're like, it's like drinking speed, and then they run even faster. I mean, they run 5.5-minute miles for 26 miles. It's insane to think about. Ethiopia, Kenya, a lot of those high plain countries. So anyway, an American winning the Boston Marathon is a big deal. Big deal. Anyway, the theory is, I've often heard that runners get older. Say again?
I think she trained in Portland.
Did you train in Portland? Makes even less sense. Sea level again. It's crazy, right? Just genetically predisposed to being awesome.
Yeah.
But the thing is, I've been told over and over again, distance runners get better as they get older. So it'd be nice to compare the top and bottom finishers to see if there's anything to that claim. So what I'm going to do is I'm going to turn on a second stat plot. I'm turning on plot 2 now. I'm leaving plot 1 on. But I'm turning on plot 2 as well. And all I've got to do is set it up so that it's representing the correct data. This is good. No, it's not. I'm on the wrong kind of plot. I've got to change this to histogram. What are these going to be? I have a vote for L1. This is definitely L1 again. That's the ages, correct? That's your data. Kelly, another good question for TI. Why don't you just call this data? It's the data, so that's L1. What's going to go in frequency?
L3.
3. That's where your bottom finishes are. L3, yes? L3? Now I'm going to zoom stat it again, just in case it's going to change the window to pick up those extra ranges. Okay. This annoys me. This annoys me. Did you see the second graph show up over the first one?
Yeah.
The problem is I can't tell who's whom. Now, I do know a little bit because we knew what the original graph looked like. I think the taller ones were the original graph. But this frustrates me with the TI. Please!
So you have one graph set to L1, L2, and the other one
Yes, ma'am. Just like, if you think about it, it's just like the data is on your data sheet, isn't it? L1, L2, L1, L3. Same exact kind of setup. So here's a way around this if you're using the TIs. The best way around this is to use Excel, obviously. But honestly, to use the TIs, there are other histogrammy types of graphs you can use besides a histogram. One of my favorites is this guy right here. This guy backed up one from the histogram. If you go to him, instead of a histogram, it'll put a dot at the top of each histogram's bar and then connect them with a line. Now, the only problem is it says X list, Y list, so we're back to that issue, but treat Y list like a frequency and just tell it L1, L3. And then the mark is the shape that it's going to put where the bars would be. So now what you'll see is, you'll see the first histogram again that you got, and then you'll see a secondary histogrammy looking thing on top of it that you can actually compare. See, there it is. So that was the other histogram, except now it's a different graph. It's not perfect. I want two histograms. But what I want, what the TI can give me, not always the same thing.
Why not use two the same?
Two the same.
Why not use two scatter plot deals?
Oh, you totally can if you want to. You totally can. The problem with that is, because the TI doesn't have color differentiation,
Don't know which one.
I like having them as different as possible so I can totally tell them apart. I wish the histograms could shade like different ways, like you can with graphs, but you can't. Again, I wish. Wish you all had PCs in your desk we can use. But we'll get to that. So in other words, looking at this, does there appear to be any credence to the claim that runners, as they get older, get better? Based just on this data, does it look like runners that are faster, or get faster as they get older? According to this, it looks like the younger runners on average are doing better in the race than the older runners. Now, I've ignored the entire middle of the race. There's like thousands of people I didn't even bother looking at. I looked at the top 5 and the bottom 5 pages. But looking at those numbers, I see more younger runners finishing in the top 5 pages than the older runners. I'm not saying it's a complete data set. I'm saying maybe I need to look at more data. Maybe I'm looking at it the wrong way. But I wanted to, that was what piqued my curiosity. What is the average age of a runner in the bottom? 43 and a half. Is that what I heard? Yeah. Madeline, 43 and a half. We have a second on 43 and a half. We've got a third. We got all in favor. Anybody opposed? Discussion? Yes, discussion. How'd you do it, Madeline? What'd you do?
One var stat.
One var stat. Just press enter, right? Wait, I think it was 43 and a half. Contest me. I get 49 and a half. Madeline's wrong.
Where's your frequency?
Where's my frequency? What the hell? There's aren't 7 runners in the bottom. Remember what I did? I made the mistake. I say this because you will do this every day for the next couple weeks until you get used to adjusting for the frequencies. You have to tell it, just like Madeline just said 100% correctly, one of our stats, L1, comma L3 in this case, yes? Tell it where your data is. If you don't tell it where your data is, it's going to assume it's all in 1. It's going to assume it's all in L1 if you don't tell it where it's data. And you can put it all in L1. You can, can't you? You can just simply go 19 and a half, 29 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 and a half, 18 times. 39 and a half, 39 and a half, 39 and a half, 28 times. Why? Sweet Jesus. No, it's not even multiplication.
43.5.
Good. I don't know. I haven't done it yet. There. Madeline's average age for the bottoms, 43.5, with a standard deviation, a much wider standard deviation. Our old standard deviation was about 9. This is more like 13. Can you see the wider standard deviation on the curve? Can you see it? The curve for the top is tight. The curve for the bottom is squatter and wider. It's roughly the same amount of people, isn't it? 75 to 81. That's almost the same amount of people. But with the top finishers, they're crunched down into a smaller age range. And the bottom finishers, they're more spread out in the age range. Hence, a larger standard deviation. We had a question, Zach. Go ahead. I thought you had a question.
I was going to ask why it was 75, and I realized it's different.
It's different, right. I had a different random sample for the bottom and the top. Very good. I wasn't pairing them off. Just grabbing a random sample. Ask me questions right now. I love the discussions. I hear discussions happening as you guys are chit-chatting with each other. Please keep that up. Eric, go, please.
I think it's in this graph.
This graph here. I turned a second graph on, my friend. So back to stat plot. So second y equals, again. Okay? Second y equals. Now, you already had plot 1 on, correct, from the previous data?
Yeah, plot 1 and plot 2.
Good. So plot 2, go to plot 2, Eric. And write, it was on a histogram. I changed it to this type right here.
Okay, I can use there though.
Just arrow down to it, and then arrow over. So use your arrow buttons on the right side of your calculator.
Well, I meant, do I hit enter?
Yep, arrow and press enter to select. Does that make sense?
Ah, that's what my card.
Aaron's awesome. She's going to help you. That's fantastic. Kelly, you had a question too. Go ahead.
That was it.
That was it. Yeah, it's always, what you're going to learn, there's a lot of little commands you're learning in here, but you're using the same ones over and over again, which is nice. So it's going to be frustrating at first, but it'll become second nature the more we do it. Go ahead, Janelle.
Second
My calculator
plot.
won't let me do 2 plots with two,
Simultaneously?
not with 2 separate.
That's the Inspire, isn't it?
plotting, yeah.
Give me time after class, we'll take a look at it. I'm learning. Is it a different Inspire than these guys have? Because we've got a little Inspire crew started.
I have the 84 plus keypad.
Oh, that should be identical to ours. Wait a minute. No, that should be the same as ours. That's perfect. That's why we changed the second plot.
But it won't let me change the second.
Yeah. Oh, I did. That's important. Hold that thought. Friends. No, this is very important. Janelle, thank you. We're going to stop and start. Janelle just got an error that you guys